All right, we're gonna do this warm up because you really need to understand composite functions because we're gonna do today the chain rule, and you really need to know what composite functions are. So this is a review of composite functions. Let f of x be this quadratic equation, and then g of x be a square root of x function. You got these two functions, and it says to find f composite g of x. So basically, f is going to eat g of x. F is going to eat g of x. All right, what do I mean by that? You're going to input, like how you usually input numbers for f. Say, what's f of 2? Okay, you don't copy this down, but let's say you input numerical like numbers in for f, and that's easy. F of 2 will be 2 squared is 4, 4 minus 3. So, but we're not inputting a numerical value. We're inputting a whole function. It's going to eat the whole function. So g of x represents x. So wherever you see an x, you're going to substitute in g of x. All right? So then you're inputting this in for every x. You're inputting it there. So then that would be square root of x is square root of x. You're squaring it minus 1. And then, so that would be f composite g of x. It cancels out. The answer is x minus 1. All right. So in the way I kind of teach it, I teach it in terms of a machine. This f is the outer function, is the machine. Let's go. So this outer function is the machine, and it's gonna eat g, f and g. So if the f function is x squared minus 1, and we're going to plug in g of x, where g of x is square root of x. And for that x, I'm going to substitute square root of x. F composite g of x is x minus 1. All right. We can go backwards and we can have g eat up f of x, meaning that g is the outer function, is the machine. We can go find g composite f of x. G composite f of x. So g is the outer function, g is the machine, f is what's going to go in. So g is square root of x, f is x squared minus 1. And for every x, you're going to substitute in x squared minus 1 in for that x. So we're going to have what? Square root of x squared minus 1. And that is g composite f of x. All right. So this is just like a quick review. If you ever, I don't know if you did it or if you don't remember, but let's go. That's what you need to know. Let's go then. Now we're going to do the chain rule. The chain rule. This is the chain rule. F prime of g of x. So what would be the derivative of f prime of g of x? It will be the derivative of the outer function evaluated at the inner function multiplied by the derivative of the inner function. Okay. The outer function, the derivative of the outer function evaluated at the inner function multiplied by the derivative of the inner function. The derivative of the outer function. Room to wait? Yes? Yeah, I don't have an answer in this class. 1208, second period. Not a problem. Okay, so the derivative of the outer function evaluated at the inner function multiplied by the derivative of the inner function. Okay, let's go. Example, let f of x equal x squared minus 1 and g of x equals square root of x. Those were the two functions we did in the warm-up. And now we're going to do the derivative f prime of g of x. Let's do f prime of g of x. What would be f prime of g of x? I don't know, I really like the way I do these little machines because I don't know, he organizes it. So we're gonna do about 5 problems doing it with my machines, the little machines I make. And after that, hopefully you get the idea of it and then we'll just go straight to doing it. Here we go. Step 1, draw the f is this f is the machine. So draw a machine, f, g of x is what is gonna go in. So f of x, what we're gonna do is write down what f of x is. F of x is x squared minus 1. And you write it on top. You draw a line and you put x squared minus 1. Then what do? Then we write down g of x. And g of x is square root of x. Write it down right here. And what this says is that we're going to take the derivative of the outer function, which is the derivative of the machine, and then evaluate it where this is going to go in for every x. And then we take the derivative of this this inner function and multiply it by whatever we get here. All right, let me just do it. Here we go. Let's take the derivative of f of x. So what's the derivative of x squared minus 1? Anybody? What's the derivative of x squared minus 1? 2x. You put it there. And now you're going to evaluate it where for every x you're going to plug in square root of x. So we're going to go here and we're going to go 2. And for that x we're going to put square root of x. And now we're going to take the derivative of this and multiply. That's what's going to go here in the back. That's what this is. G prime of x. So we're going to take g prime of x here. What's the derivative of square root of x? Didn't I tell you to memorize that thing? Yep, I got it. Isn't it 1 over 2 square root of x, is it? Yes or no? Yes, thank you. So, I think it is. Well, so it's going to be 1/2 square root of x is at the bottom. But what's going to happen now that you have here this? Doesn't everything cancel out? 2 cancel with 2 and square root of x cancel with square root of x. Isn't the answer 1? Yes? That's how it goes. That's what we need to practice over and over. Okay? So this is my method. I came up with this method. 2x square root of x, plug it in for x. 2 square root of x, take the derivative square root of x and put it in the back. And then everything cancels out and the answer is 1. All right, let's go. Let's do the other. Let's do it backwards. Find g prime of f of x. So the outer function is the machine. The outer function is the monster eating, or it's the one eating the other function. So g, this is g of x. And so what do I put here? G of x. What's g of x? G of x is square root of x. You see? And we're going to take the derivative of that. Well, this is the f of x is here. And f of x is this x squared minus 1. So what did we say was the derivative of square root of x? After a while, it just becomes, hopefully, square root of x. What's square root of x? You need to remember. 1 over what? 2 square root of x? Yes? And now we're going to plugging this in for every x, which there's only one x, no? So it's going to be what? 1 over 2 square root of what? X squared minus 1? And then we take the derivative of f of x. What's the derivative of that? X squared minus 1? 2x. We take the derivative of this and then slap it on here. That's what that guy says on the video. What can we do here? What's the only thing we can do here? Cancel out the 2's, no? And so the answer to this is going to be what? X over square root of x squared minus 1. All right, let's go. Find the following derivatives and differentiate this. Man, here it is. We're like, what's the outer function? What's the inner function? That's the problem we get sometimes, is being able to recognize what's the outer and inner. So let's go. What's the outer function? Anybody? What do you think is going to be the outer function? All right. What's the outer function? It's okay to make guesses. It's okay, somebody, anybody. What do you think is the outer function? It's going to be this, whatever this is, x to the power of 100. And then you plug it in for x, this x cubed minus 1. I think that's when they present something like this, it's like what's outer and what's inner and like that. So now that you have that, now we're going to take the derivative of x to the 100. What is that? What's the derivative of x to the 100th power? 100 times x what? To the 99? And then we're going to evaluate this, put it into x, yes? So then it's going to be what? 100 x cubed minus 1 to the 99. And then we take the derivative of this, which is going to be what is the derivative of that? What's the derivative of this? Squared, 3x squared. And you put out right here in the back here, 3x squared. Well, this is the derivative, no? But we can what? We can go ahead and multiply 100 times 3. So it would be what? 300. Put that x squared right next to it, I guess, also. And x cubed minus 1 to the 99 power. That is the derivative right there. Is that good, Jacob? All right, problem 2, let's go. Pretty much the same kind of process, that one, it's the same process. say it just while you're working on it. Say, what's the outer function? X to the 10th power. The inner function is going to be x squared plus 3x plus 7. Take the derivative of x to the 10th. The derivative of x to the 10th is what? 10x to the 9th power, 10x to the 9th power. And we're going to evaluate it at this. So this whole thing is going to be going into the x. So it'll be 10x squared plus 3x plus 7 to the power of 9. And then we take the derivative of this. And the derivative of this is going to be 3. No, what am I doing? It'll be what? 2x plus 3. So put it in the back over here, 2x plus 3, 2x plus 3. This should be good enough. That's enough. This is good enough, but if it's a multiple choice, again, you're going to have to simplify it to whatever the answer is, no? I would bet maybe they would have multiplied 10 times this and get an answer. But that's enough. That's good enough, I think. Let's see. Yeah, this is all right. Continue. Let's continue on practicing. Number 3. What would be the derivative of this? What's the outer function? ln x. ln x. The inner function would be x squared plus 3x. So what's the derivative of ln x? 1 over x. We're going to evaluate this, plug it in there. So we get 1 over x squared plus 3x. We take the derivative of this, which is 2x plus 3. And then you just put it over here, which gives you on top 2x plus 3 over x squared plus 3x. And there's nothing more we can do with that. Continue. Let's go. Number 4. Yeah, like I said, after a while, once you get the steps, then you probably don't need the machine I draw. But you have to be able to recognize inner and outer. What's the inner and the outer? Same. Outer is ln x, 1 over x. Derivative, this is the inner, sine x. Derivative of sine x. I'm going to go here. Derivative of sine is cosine x. Yes, then, well, I'm just skipping steps here. Then go 1 over sine x. And then put that on top, because you multiply it, it's going to put it here. So it is going to be what? Cosine x over sine x. But what is cosine x over sine x? Cotangent x. right. Continue. Let's go. Number 5. Outer function. What's the outer function? Sin x squared. Derivative of sin x is cosine x. Evaluated cosine x squared. The derivative of cosine of x squared is 2x. So it'll be 2x cosine x squared is the derivative of prime of x. All right. All right, number 6. Let's go number 6. This is where people get confused. People get confused on number 6. What's the outer function? What's the outer function? Outer function. I don't. Could it work in the? No. Somebody else. Give me. What do you think is the outer function? X squared. Yes, x squared. And then this inner function sin x. Look, this is really x squared, and then you plug it in for x sin x. That's why people are confused on it. X squared 2x. Evaluate at that, it'll be 2 sin x. Derivative of sin x is cosine x. So it is going to be 2 sin x cosine x. Could it work? What you could actually do, look, you could do the product rule. Couldn't you do the product rule? See, what happens here if I wanted to do this quickly? F of x equals what? Sin x times sin x. If you have sin x times sin x, well, hold on. Well, it is. You could. Why not? This is a function, that's a function. Oh, no. Let's see. Am I going to do this? Let me sin x. The first and the second sin x. I got to move on, but let's see. Sin x. Yes, it does work. Does it? The first and the second. Plus, is it plus a second? Times the derivative of the first? The derivative of the first is what? Hold on. Yeah. Yes, it does. Why? Because how many sin x, cosine x do we have? We have 2 of them, no? You could do it, but that's not the lesson for today. The lesson is this. But you could do the product rule for it. Anyways. All right, let me slow down, take a break. Maybe like 5 minutes to copy this down. They're giving you all the information. All right, can we do this without the machines I do? Let's see, well, just the definition of it, h prime of x. H prime of x is f prime at g of x times g prime of x. That's h prime at 2, h prime at 2, f prime at g of 2 times g prime at 2. What is g prime at 2? What's g prime at 2? Negative 2 times, what's g of 2? F prime at 5? Oh, no, I don't need this. F prime, what's f prime at 5? Let me see. F prime at 5? F prime at 5 is 7, and so it's going to be 7 times negative 2, this is the times, it's negative 14. So h prime at 2 should be negative 14, or I don't know, did I mess up? Yeah. All right, let's go to B. Let's do B. If h of x is equal to this, if h of x is equal to this, then what is h prime of 5? Well, the inner function is f of x, the outer function is square root of x. Yeah. So h prime of x, h prime of x. Maybe I need my machine here. I need my machine because I can't visualize it. All right, here's my machine here. And then I said, what did I say was what's the outer? Square root of x. Square root of x. And the inner is f of x. So square root of x, oh, isn't that 1 over 2 square root of x? Yeah. Yeah. And then we're going to plug in f of x. So it'd be 1/2 f of x, f of x, f of x. Yeah, f of x goes in for x right there, and f prime of x times f prime of x. So this is be this will be h prime of x, h prime of x, and now we can evaluate h prime of 5. H prime of 5 will equal to 1/2 square root of f of 5. Times f of f prime at 5. So 1/2 f of 5, what's f of 5 is 4, square root of 4. And then f prime of 5, f prime of 5 is 7. So it should be 7 over square root of 4 is 2, 2 times 2 is 4, 7/4. Yeah? Yes, no? I hope it is. Let me see. One more. Let's do one more. One more. Last one we're doing here. the graph of the functions f and g are shown in the figure. Let u of x equal that, v of x equal that, and w of x equal that. Find each derivative if it exists. If it does not exist, explain why. All right, what's y prime of 1? 29. Yep, we got 15 minutes to finish this. I have it on the website, so you can go back and copy all this down if you need to. But let's go ahead and work it out already. Let's just take a look at it and let's do it. U prime of 1 is dealing with this function here. So we're gonna go U prime. So U prime of x will equal to f prime of g of x times g prime of x. And then we're going to do u prime at 1. U prime at 1 is f prime at g of 1 times g prime of 1. So, what is g prime at 1? What's g prime at 1? -3? G prime at 1, you're going to go to 1 and go to g. G is green. G, so you're looking at this. It's a line. So find the slope of this line. So it's going to go down 1, 2, 3 over 1, -3. This is -3, yes. G of 1. What is g of 1? G of 1. Isn't that 3? Did I see? Yeah, isn't that 3? G of 1 is 3. But it's going to be evaluated f prime at 3. F prime at 3. What's f prime at 3? F prime at 3. Right here, no? What's f prime at 3? It's a line again. That's so there. -1 over 1, -1, 1, 2, 3, 4, -1/4. So -1/4 times -3. So it's going to be 3/4. So 3/4 is the answer. Okay, v prime at 1. So you want to know what v of x is first? V prime of x. V prime of x, and we're looking now at this function here, this composite function, g prime f of x times f prime of x. So we're going to do v prime at 1, g prime at f of 1, evaluate f of 1, times f prime of 1. F prime at 1. F prime at 1. What's f prime at 1? Did we not just already do that? Is this? Is this? Yes? F prime at 1? F. No, it's F. F at 1. This one. So it's going to be what? 2. Yes, 2. 2. And then this is going to be G prime at f of 1. What's f of 1? 2. So now what's g prime at 2? G prime at 2. Oh no! What's going on here? Isn't that a corner? It does not exist. So this is not going to exist. G prime at 2? Yep, not going to exist because of the corner. Because G is not differentiable at x equal to 2. Last one. W prime at 1. W prime of x is equal to G prime G of x times G prime of x. W prime at 1. G prime at G of 1 times G prime of 1. Okay, so G prime of 1, we did G prime of 1. G prime at 1 is negative 3. So this is negative 3 times G prime at G of 1. G prime at G of 1. What's G of 1? 3. And now we got G prime at 3. G prime at 3. Is that 2/3? 2/3. So this is 2/3. 2/3 times negative 3, which is negative 2. You're gonna have to go to the website and look at this and figure it out. Find an equation tangent to the it's. You're gonna write down your y minus mx minus. So you got this minus 2. You got the 3, 2 and 3. You take the derivative of this. Take the derivative, evaluate it at 2, and then you find the improvement here. Yes. All right. That's it.